Now let's look at negative exponents. A negative exponent moves the number from the numerator to denominator and vice versa. So here we have a to the negative b, so that's a base of a with a negative exponent, and that equals 1 over a to the positive b. It was a negative exponent in the numerator, and when it was moved to the denominator, it became a positive exponent. We also have a to the b, which is a positive exponent for a, is equal to 1 over a to the negative b. It was a positive exponent in the numerator, and now it is a negative exponent in the denominator. When the exponent moves from numerator to denominator, it changes the sign. This is based on the multiplication rule and zero exponent rules. So let's use as an example a base of 3. So using the multiplication rule first, let's explore if we had 3 to the negative 1 times 3 to the positive 1. Our multiplication property would tell us to add those exponents. So that would be equal to 3 to the negative 1 plus 1. But negative 1 plus 1 is a sum of 0. So 3 to the negative 1 times 3 to the positive 1 is equal to 3 to the 0. Well, using our zero exponent rule, we know any non-zero base raised to the 0 power is equal to 1. So we can change 3 to the 0 equal to 1. So 3 to the negative 1 times 3 to the positive 1 is equal to the number 1 itself. So now we also know that any number multiplied by its inverse is 1. So if 3 to the first has an inverse of 1 over 3 to the first, we would know that 1 over 3 to the first times 3 to the first is equal to 1. Again, that's any number multiplied by its inverse is 1. So 3 to the first times its inverse of 1 over 3 to the first is equal to 1. So if we take our two equations and compare them, we can see that 1 over 3 to the first is equal to 3 to the negative 1. Right? Everything else is equal. Then we have 3 to the first, 3 to the first, 1 and 1. So 3 to the negative 1 equals 1 over 3 to the positive 1. And that's how we can look at our negative exponent rule. That negative 1 exponent represents any negative exponent, and the base of 3 represents any base of a. So again, a negative exponent moves the number from the numerator to denominator and vice versa. So here it is as a formal definition. We have x to the negative 1 is equal to 1 over x, where x cannot equal 0. So again, that's any base raised to our negative exponent is going to move it to the denominator, or vice versa. If it was in the denominator, it would move to the numerator. But why is that x cannot be equal to 0 included at the end? Why can't we have a base of 0? Let's find out. So can we raise 0 to a negative exponent? That becomes the question. Can we have that base of 0 for our rule? Well, let's actually try it. Let's see what would happen. So if we had a base of 0, let's say raised to the negative 1. So then we would move that to the denominator to become a positive 1. So 0 to the negative 1 would equal 1 over 0 to the positive 1. And 0 to the positive 1 exponent is just 0. So that would be 1 over 0. But 0 in the denominator makes an undefined value, so we wouldn't be able to do that. We wouldn't be able to evaluate 0 to the negative 1. What about 0 to the negative 2? Well, 0 to the negative 2 is equal to 1 over 0 to the positive 2, but 0 to the positive 2 also has a product of 0. That's 0 times 0, and that's, again, a 0 in the denominator, making it undefined. That would be 1 over 0. What about 0 to the negative 10? Well, that would be equal to 1 over 0 to the 10th, which is 0 multiplied 10 times, which still has that product of 0 in the denominator, making it undefined. So see the pattern. What would 0 to the negative 6 be? What would 0 to the negative 16, 0 to the negative 18, 0 to the negative 100, 0 to the negative 1000? So come up with the conclusion and see that whenever we raise 0 to a negative exponent, it will always be undefined because you have that product of 0 in the denominator, and we can't divide by 0. So this also explains why that x cannot be equal to 0 was included at the end of our definition. Again, if we go back, we have to see that by definition, x to the negative 1 is equal to 1 over x, but we cannot have that base of 0 due to the fact that 1 over 0 would be undefined. So we have to be careful of that when we're looking with and working with negative exponents.